physical chemistry. In this lesson, we use PVT data for carbon dioxide to regress a virial equation of state through the second and third virial coefficients, and then predict the compressibility factor Z at 320 Kelvin and 100 bar. We will look at this chemically, mathematically, statistically, and graphically. The compressibility factor Z is defined as PV bar over RT. The virial equation of state in density form is Z equals 1 plus B2 of T times rho plus B3 of T times rho squared, truncated after the third virial. Here is a clean PVT dataset at 320 Kelvin for carbon dioxide. We will use consistent units, bar, liter per mole, and mole per liter. We fix R as 0.08314 liter bar per mole Kelvin, and T as 320 Kelvin. To regress B2 and B3, we rewrite the model as Z minus 1 equals B2 times rho plus B3 times rho squared. This is linear in the unknown coefficients. We build a design matrix X with columns rho and rho squared, and the response vector Y equals Z minus 1. We then solve by least squares. Beta equals X transpose X inverse times X transpose Y. Using the data above, the fitted coefficients at 320 Kelvin are B2 hat equals negative 0.10 liter per mole, and B3 hat equals 0.003 liter squared per mole squared. Chemically, a negative B2 indicates net attractions at this temperature, and a small positive B3 captures higher order crowding effects. Graphically, plot Z versus rho and overlay the fitted quadratic curve. Z equals 1 plus B2 rho plus B3 rho squared. Notice the gentle downward curvature from attractions, followed by a slight upturn captured by B3. Statistically, the least squares residuals are tiny for this clean data, and the coefficient of determination, R squared, is essentially 1. Always check residuals to ensure the truncated virial captures the trend over your data range. To predict Z at 100 bar without solving for density, we use the pressure virial form. We convert coefficients as B pressure equals B2 over RT and C pressure equals B3 minus B2 squared, all divided by RT squared. Then Z of P equals 1 plus B pressure times P plus C pressure times P squared. Let us compute. RT equals 26.6048 bar liter per mole. B pressure equals B2 over RT equals minus 0.100 over 26.6048 equals minus 0.003759 per bar. C pressure equals B3 minus B2 squared over RT squared equals 0.003 minus 0.010 over 707.815. 4 equals minus 0.00010 per bar squared. Finally, Z at 100 bar equals 1 plus B pressure times 100 plus C pressure times 100 squared, which gives about 0.525. Graphically, here is Z versus P from 0 to 100 bar using the pressure virial form, with the prediction highlighted at 100 bar. Summary: chemically, B2 negative signals net attractions, B3 positive captures crowding. Mathematically, we fit a linear model in rho and rho squared to obtain B2 and B3. Statistically, residuals and R squared confirm the model on the chosen range. Graphically, the Z versus rho and Z versus P plots visualize both the fit and the prediction.